Building on the principles of electrophilic alkene additions, this episode focuses on epoxidation, the direct, one-step conversion of an alkene into a three-membered cyclic epoxide using a peracid reagent such as m-chloroperoxybenzoic acid, or simply mCPBA. We will examine the concerted peracid mechanism that converts propene into propylene oxide and highlight the syn stereochemistry it produces. Epoxidation installs one oxygen across the CC double bond in a stereospecific syn fashion. Because the process is concerted, alkene geometry is preserved and no carbocation rearrangement occurs. For propene, peracid epoxidation yields propylene oxide. Under achiral conditions, the prochiral alkene gives a racemic mixture of R and S enantiomers. For reference, 2-methyloxyrane can also be called 1,2-epoxypropane or propylene oxide, but 2-methyloxyrane is the IUPAC name. Peracid epoxidation is concerted. Bonds reorganize synchronously within a concerted transition state, guaranteeing syn stereochemistry and avoiding discrete carbocation or radical intermediates. Pre-reaction alignment, approach and activation. To begin, let's display the two molecular models on the screen in an optimized configuration for explaining this reaction. The alkene pi bond aligns with the peracid oxygen, pre-organizing the orbitals for synchronous bond reorganization. Concerted bond reorganization and transition state collapse. In the concerted transition state, all events occur simultaneously. The OO bond elongates and cleaves as the two CO bonds begin to form. Crucially, this oxygen transfer is synchronized with an intramolecular proton transfer from the peracid's hydroxyl group to the carbonyl oxygen. This full reorganization causes the transition state to collapse directly, yielding the three-membered epoxide product and the corresponding carboxylic acid byproduct without forming any discrete, separate intermediates. This stereospecific reaction results in a racemic mixture of the epoxide product. Let's summarize. First, the peracid reagent, specifically mCPBA, adopts a stabilized structure with an internal hydrogen bond, aligning its electrophilic oxygen and preparing the orbitals for the attack. And then, the alkene's pi electrons initiate a simultaneous, concerted transition state where the OO bond cleaves, two CO bonds form, and a proton transfers, directly yielding the three-membered epoxide ring in a syn orientation. Let's organize by keywords. Epoxidation proceeds through a concerted transition state. The reaction follows strict syn addition due to the single-step oxygen transfer mechanism. This mechanism prevents carbocation rearrangements and produces a racemic mixture under achiral conditions. To wrap up, those who wish to deepen their understanding of epoxidation and stereochemistry are encouraged to study the following topics. If this video was helpful, we'd really appreciate it if you could share it with others. See you in the next reaction.